All right, so the next stage is talking a little bit about this early embryonic development. So we talked about we got to the point of the blastocyst stage, and now we're going to see this embryo develop, and it's going to be the very, very early stages of development. So if we look first at the sort of timeline of development, what we see is this is a really useful image for sort of conceiving of all of the timelines that are overlapping here. So on the very bottom, what we have is sort of pregnancy time, and then pregnancy time is really about, and it's broken up into weeks and months, is really about the maternal body and the maternal ovarian cycle. So if you notice, the first week of pregnancy actually starts with the first day of the last menstrual period. Okay? So if you notice here, fertilization is happening halfway through the first month of pregnancy. So technically, the first 2 weeks of a woman's ovarian cycle, which includes the development of the oocyte, ovulation, and then leading up to fertilization. So those 2 weeks where she's technically not pregnant at all is included in the weeks of pregnancy. Okay? So what you'll always find is that there's two terms, really. There's terms that are often used interchangeably, but they're not, which is the weeks of gestation, which has to do with the age of the embryo, and the weeks of pregnancy, which has to do with, which includes 2 weeks before the embryo develops. Okay? So embryonic age and pregnancy time has a difference of 2 weeks. So you notice that implantation happens about 1 week after fertilization, okay? And the true embryonic period happens around that implantation stage. Okay? And before that stage, we can still call it embryonic, but before that stage, it's the pre-implantation stage. Okay? So once that implantation is successful and it's established, then we kind of have the beginning of what could be a viable pregnancy. It also happens to coincide with the first day of the missed period. So it's really not until that embryo is implanted that a woman sort of discovers that she has a pregnancy, okay, or is pregnant. Then the next several weeks, up until about 8 weeks embryonic age, 10 weeks of pregnancy, we're in this highly vulnerable stage called the embryonic period. And this is a period that is, I call it highly vulnerable because there's an enormous amount of development that's happening in the embryonic stage. This is sort of first trimester period of pregnancy. And it's during this period of time that all of the major body systems are forming, all of the organs are forming. And so by the time you get by the time that embryo hits 9 weeks, or you're leaving sort of that first trimester, your basic body plan, right? The organs may not be fully functional, but all of the basic body structure is established. Okay, so anything that affects the pregnancy in this early stage can lead to some major congenital malformations and some major problems and birth defects. So we call it a highly vulnerable stage because it can create the biggest problems. Beyond that, we're now into the fetal period, and then most pregnancies will go until about 39 to 41 weeks, okay, pregnancy, which equals about 37 to 39 weeks embryonic age. So the last we saw the last thing we saw in this in development, we had the blastocyst stage, right? And in the blastocyst stage, we had two major cell types. We had the trophoblast cells, and we had the inner mast cell layer. The next stage after the inner mast cell layer is that we're going to form two cell types. We're going to form what's called the hypoblast and the epiblast. And if you're following the embryo is going to form out of this epiblast. The hypoblast is going to become what we call extra embryonic tissue, meaning tissue that is not part of the body of the embryo but supports the embryo. Then we move into, you notice this epiblast starts to form a cavity inside, okay? And that cavity gets bigger and bigger. Okay? And that cavity, it's hard to imagine yet, but that cavity is going to form the amniotic sac. Okay? And we'll see what that we'll see that happening as we go through. But you notice that as that those blue cells, which are embryonic, as that's developing, we also have in this hypoblast layer, we have these cells that are emerging out of the hypoblast layer, okay? And they are going to form something that we call extra embryonic mesoderm, which is again still supportive tissue. It's not part of the embryo. And that hypoblast is actually forming something called the yolk sac. And again, the yolk sac is supportive tissue. Among other things, it actually helps produce red blood cells for the embryo before the embryo's bone marrow can produce red blood cells. Okay? And then if you notice this trophoblast layer, the layer that I said was going to become the placenta, it's also elaborating, and it's starting to form these little ridges, right, which are going to become primitive structures that we call villi, which are going to eventually form the chorionic villi, which is the fetal portion of the placenta. Okay, so I know everything's very, seems a little complicated and a little hard to wrap your head around yet, but it'll become easier as we go through. So just to remind us where we were, okay, so we started off here with the single-celled zygote, and then we started to undergo layers of cleavage. And then we get to that blastocyst stage, and we form those two cell types, trophoblast and the inner cell mass layer. The trophoblast is going to continue to differentiate, but all of the cells here are going to be placenta. Okay? And then the inner mast cell undergoes another major determination step to form the hypoblast cells that become extra embryonic tissue, supportive tissue, and the epiblast cell that actually becomes the embryo. And the epiblast cell forms the amniotic membrane, and it forms embryonic epiblast. And that embryonic epiblast, from there, you get basically all of the cell layers that become all of the organs of the body. And ultimately, what we're going to get to is the concept of the three germ layers, which are the three primary layers, embryonic cell types, which include ectoderm, mesoderm, and endoderm. And it's from these three germ layers, ectoderm, mesoderm, endoderm, that all of the body structures arise from. Okay? So we'll see what that looks like as we go through. So at day 16, the embryo doesn't really look like much of anything, right? Because at this stage, it's really just a flattened disc of cells. And it's kind of hard to imagine, but as we go through, it's going to become more clear that this portion of the embryo on top here, this bubble on the top, is actually eventually going to become the amniotic sac. And this, in the fluid inside, is actually amniotic fluid. So the amniotic sac and the amniotic fluid at this point is sitting on top of the embryo. And the embryo is just this flat disc of cells. Now, at first, this flat disc of cells is just composed of a single layer of epiblast and then hypoblast. Okay? And then that epiblast layer is going to form endoderm, and then it's going to form mesoderm. So you can see this here. Eventually we're going to get, at day 20, to the 3 germ layers. Endoderm at the bottom, mesoderm in the middle, and ectoderm on top. And this formation of these 3 germ layers, it's actually called gastrulation, and it involves the formation of this thing called the primitive streak. It's this streak on the top of the embryo. And you can see the arrows pointing in. Cells on the top start to migrate in to form the endoderm and the mesoderm. Okay. So we're going to go to a YouTube clip right now to just watch a little animation of this happening. Okay, so let's find this YouTube clip over here. Okay, so gastrulation. So we're looking at a cross-section of the embryonic disc. So on the top we've got the epiblast, the primitive streak, the hypoblast. Now we formed the endoderm layer. Okay, and we still have the epiblast on top. So now from the primitive streak, we're going to see the movement of cells in to form the mesoderm. Okay. And that is the process of gastrulation, okay, and the formation of the 3 germ layers.